All right, so today we are going to learn about a second way of doing substitution, of solving a system of equations by substitution. Last lesson, we learned how to do it here from example 1, where we get y equals, well, we have both equations already solved for one of the variables. Now, this second example, we're going to see that only one of the equations is solved for a variable. So in this case here, we have the two equations. We have that equation and we have that equation. So the first equation says y is equal to negative 3x plus 21. The second equation says negative x plus 4y is equal to 6. So what we're going to notice here is we're going to see that y is equal to negative 3x plus 21. So wherever you see y is equal to that. You know, it's not just equal to a number, negative 3 is equal to negative 3x, but it's also equal to plus 21. So wherever we see y, we see negative 3x plus 21. Well, if you notice, on this second equation, we see y here also. We see it right there. So what we're going to do is we're going to substitute. We're going to substitute this y here for this negative 3x plus 21. Because remember, y is equal to these two things right here, these two terms. So watch what I'm going to do. So I'm going to rewrite the second equation. Okay? I'm going to rewrite it. Okay, negative x plus 4, but I'm going to put parentheses because I'm going to substitute for y. And I'm going to put in these two terms here, negative 3x plus 21. And then I'm going to finish it, equals 6. So what I did is I substituted, right? Now from here, we do multiplication, 4 times negative 3 and 4 times 21. That gives us negative 12x. And then 4 times 21 is 84, equals 6. Now, let's not forget that we still have this minus x here, minus 1x. I'm going to do that. So I'm going to combine like terms. This is perfect here. I have the x's next to each other, so I'm going to do that. So I have a negative 1 and a negative 12. Well, they're the same sign, so I'm going to add them. 12 and 1 is 13x. And it's a negative because 12 is negative and 12 is bigger. Now, don't forget your line of separation here. So I want to solve for x. I want to get x by itself, just like that. So I'm going to take this plus 84 because I only want x's here. I'm going to take this plus 84 and I'm going to move it over to this side. I'm going to say minus 84, just like that. So I have a positive 6 and a minus 84. So they're different signs. So I subtract 84 minus 6 is 78. And it's a negative because 84 is bigger. So I'm going to put a negative there. Now I still have negative 13x. Right? So, remember negative 13 times x here. So the opposite of multiplying is dividing. So I'm going to cross out negative 13 and I'm going to divide by negative 13 here. A negative divided by a negative is a positive. 78 divided by 13 is 6. So my x is equal to 6. And remember, we are looking for x, comma, y, right? So I've found my x. But now I need to find y. So if you notice on this first equation, y is already by itself. So I'm going to bring over this first equation. So I'm going to say y equals negative 3, but I'm not going to put x Because look, I already know what x is. X is. X is equal to 6. So I'm going to put a parentheses, and I'm going to put 6. And then I'm going to write the rest of it. Plus 21. So I'm going to draw my line of separation here. My goal is to get y by itself, which it already is. Perfect. So I see that negative 3 times 6 is negative 18. So I write negative 18. I bring down my plus 21. So I see that these two are different signs, so I subtract. 21 minus 18 is 3. And my 21 is bigger than 18, and 21 is a positive, so that's a positive as well. So I have y is equal to 3. So I have my x, and I have my y. So my solution is x, 6, comma, y, 3. And there you go. That's where these two equations cross if we were to graph them, 6, comma, 3. But no need to graph because we're doing them here algebraically. So let's look at a couple of examples you're going to see on Delta Math here. So let's take a look. So let's take a look at this first example. It says solve the system by substitution, right? So I'm going to notice that x is equal to minus 2y. Well, where else do I see 2x? X, I'm sorry. I see it up there. So I'm going to substitute negative 2y wherever I see x on this first equation. So I'm going to draw or write this first equation again, negative 7. But instead of writing x, I'm going to write negative 2y. Negative 2y in parentheses. And now I'll write the rest of it. Minus 10y equals 40. Minus 10y equals 40. So I draw my line of separation here. My goal is to solve for y. So I get y equals. So I have negative 7y times negative 2, negative 7 times negative 2y, excuse me. Negative times negative is positive. 7 times 2 is 14, positive 14y. And I bring down my negative 10y, and I bring down my 40. Well, these two are both y's. They're both like terms, so I can combine them. So 14 minus 10 is 4. So I'm going to write it over here on this side, 4y, and I bring down my 40. Now, I remember that my 4y means 4 times y. So the opposite of multiplying, I cross out 4, is dividing by 4. So 40 divided by 4 is 10. So my y is equal to 10. See? So the first one gives me the first equation, just like this one here. Right? Okay. Now I'm going to find my x, because I have my y. Because remember, I need to find x, comma, y. So I'm going to find x now. So if you notice the second equation, x is already by itself. So I'm just going to bring over this. X is equal to negative 2. But instead of writing y, I already know what y is. I'm going to write a parentheses with a 10 inside. So my goal is to get x by itself, which it already is. Negative 2 times 10, a negative times a positive is a negative. 2 times 10 is 20. So there you go. That's my x. And remember, my answer is x comma y. So x is negative 20, comma, my y is 10. And that is my solution for that example right there. Okay? One more example here. Let's see. So we're going to solve this second one here that says solve the system of equations. So again, I'm going to notice that y is already by itself here. Y is equal to negative 2x. So wherever I see y, I'm going to put negative 2x. So I'm going to rewrite this equation here. 4x plus 10. But instead of putting y, I'm going to put parentheses negative 2x is equal to 16. And I'm going to draw my line of separation here. And my goal is to get x by itself. So I'm going to multiply 10 times negative 2. A positive times a negative is a negative. 10 times 2 is 20x. Now, this 4x, nothing happened to it, so I got to bring it down just like that. And I bring down my 16. So I'm going to combine these two because these are both x's. A positive 4 and a negative 20, they are different signs. So I subtract 20 minus 4 is 16. I'm going to put it over here. X, and it's a negative because 20 is bigger than 4 and 20 is a negative. So I'm going to bring down this 16 here. And I know that 16x means 16 times x. And what is the opposite of multiplying? Exactly, dividing. So I cross out negative 16 here. And when I bring it over to this side of the line, it's going to divide by negative 16. A positive divided by a negative is a negative. 16 divided by 1 is 1. So I get x is equal to negative 1. So again, I look back up here and I see that y is already by itself because I already have x. I need to find y, so I'm going to bring that over, right? And I'm going to say, I'm going to copy it over, negative 2, but instead of writing x, I already know what x is. X is negative 1. Is equal to y, equal to y. So I'm going to draw my line of separation here. I want to get y by itself, which it already is. And now I'm going to multiply these two. Negative times a negative is a positive. 2 times 1 is 2. And that's the only thing that's left. So I bring it down and I get y is equal to 2. So my solution has to be in x comma y form, right? So x negative 1, comma, y, positive 2. And there you go. That's my solution for that. And these are the type of problems that you're going to do in this assignment that involves substitution. A second type of substitution, different than the prior lesson. There's the, up here is the first example. And up down here is the second example.